So today I'll be talking a little bit about my independent study and kind of all the activities that went into it and some of the reflection I got out of it. So kind of a quick overview of everything that happened, or that we'll be talking about here in the presentation. First off, I'll talk about the goals of the independent study, kind of the general overview. And then we'll look at kind of the three major components: the GIS skill building, the operations research staffing distribution component, and then finally the literature review. And then with that, kind of culminating with our semester-wide reflection. So the primary goals of the independent study included continuing analysis of data that I'd gotten in Guatemala during my Chapman Scholars Program, and we'll talk about a little bit more in a second. But then kind of within those specific projects, I first wanted to build data visualization skill sets, primarily in kind of the GIS setting. I also wanted to kind of have some more hands-on practice and work with OPL methodologies and operations research. And then lastly, I wanted to build a foundational and kind of a working knowledge of quantization and mixed methods to kind of bring me into grad school with. So flashing back to the summer of 2018, I traveled to Joyaba, Guatemala as part of a research trip funded by the Chapman Scholars Program. And while there, I was interested in performing kind of a mixed methodologies approach to studying healthcare from both an industrial engineering and an anthropological viewpoint. And so while there, I went around and did a lot of video interviews and ethnography. And overall, throughout that process, I collected a total of about 50 interviews, meeting with a number of different community members, getting thoughts on the healthcare system, hearing the healthcare stories, things of that nature. And from those interviews, I learned a lot about kind of the qualitative aspects of the healthcare system there. And I also worked with the kind of municipality-wide health center and health department to get health statistics and other kind of more broad quantitative information. And in the past few years, I've done a lot of kind of the qualitative work already, culminating in a lecture in my medical anthropology class in December of 2018. But I never really had the time or necessarily even the technical skills necessary to do kind of the quantitative analysis. And so that's kind of sets the stage for the independent study. And so the first component, as I mentioned previously, was the GIS kind of skill building activities. And at the beginning of the semester, I had really no experience with GIS whatsoever, but I wanted to learn and I wanted to do something with the data that I'd received when I was in Guatemala. And so with that, the first thing was collecting that data, cleaning it, and then we plotted the population and mortality data for the northern section of Joyaba, containing about 3 out of the 30, or out of the rather 13 health territories. And so kind of throughout this process, I used 3 major platforms: ArcGIS, QGIS, and Tableau. And so on screen right now is the ArcGIS output. And as you can see, the red indicates kind of the density of the mortality. So the more red, the higher the mortalities, and the larger the circle, the larger the population. And so this process was kind of more or less repeated with the same data sets on QGIS shown here, and then lastly on Tableau shown here. And the original kind of goal was to kind of see if there was maybe a tie between proximity to a healthcare or a health post and maybe a reduced mortality rate in comparison to other places. However, what kind of came out of this analysis based on the visualization is that there's not necessarily any tie between proximity to a health post and actual mortality rate, because based on the numbers provided to us in some of those health statistics, the mortality rate was maybe about 0.4% for the population, which is well below Guatemala's national average, and really I think a conceivable even mortality rate for that area. And so what seems to have emerged from this data is that in all actuality, it kind of seems like more so the proximity to a healthcare location, whether it be a health post or a hospital, seems to be a better indicator for whether or not mortalities are reported. And also, obviously, areas with higher population tended to report more populations, but within that, it tended to be the ones closest to the health post that reported the greatest amount. And so rather than, I think, reflecting true statistics on health, it reflected maybe some of the qualitative information about kind of healthcare and community relations. So kind of from this aspect of the independent study, I was able to understand the process of map making. I definitely gained a lot of experience creating maps and gained confidence on those 3 platforms. And I also experienced some frustrations and learned some about the learning process, which I'll discuss kind of at the end with the reflection. So then the second part of the independent study was the operations research model. And operations research is kind of a piece of industrial engineering at K-State, but kind of broadly, it's a methodology decision making based on using pretty much mathematical models to kind of chase after a certain goal to optimize, and then from those outputs have better decision making understandings and kind of a process there. And so with this operations research model, the goal was to create an equitable distribution of healthcare workers in Hawaii using information that we were provided in the census and also about kind of healthcare worker amounts and totals, and kind of looking at the effective or like the most effective way to distribute health workers based on that population data. And we wanted to account for the different levels of healthcare workers, whether it be auxiliary or licensed or professional nurses or doctors, things like that. And then overarching, obviously there was also a goal to kind of build an exposure and experience to using CPLEX in realistic applications. So as I mentioned previously, with this health statistics collected, there's information about each health territory and health sector, which are kind of Hoiaba's ways of breaking up their areas for kind of manageable healthcare areas. And so kind of with that knowledge moving in, we decided to take each sector and equalize it for the entire municipality. So the model for operations research really kind of foundationally lies on the objective function, which in our case was maximizing the health benefit, which we took as kind of a marginal gain times the number of a given healthcare type worker. And so pretty much the number of workers times their benefit. And our goal was to maximize that based on this kind of equality constraint that I'll talk about a little bit later. So with that, our decision variables looked like, kind of the number of each medical type in each location. And then we also had a counting variable and obviously our health benefit. And then lastly, our flex variable, which I'll discuss a little bit later on with our sensitivity analysis, that helped us fine tune our model to function well. So then within operations research, kind of the main mathematical aspect is the constraints. And so obviously for our constraints here, there are staff limitations, certain health post staffing requirements where there had to be certain types of healthcare staff, primarily an auxiliary nurse and a digitizer, kind of a records keeper at each health post. And then we had, kind of some mathematical ways to kind of work out our health benefits. However, the meat of kind of what was going on in the model took place in the flow quality constraints, where we took the health benefit of a given region, divided it by the population, and then kind of compared that to each of the other health sectors. And our goal was to make that more or less equal within about 0.002. And that was a parameter that we decided on kind of throughout the process of using that flex variable. So kind of with all that math, we put it into CPLEX, a coding language based loosely on C, created by IBM, that's specifically made for operations research and OPL. And from that, we got our model outputs. And here's kind of the wide-reaching table, but you can see that it's not necessarily the easiest to understand or visualize. Has some general geographic information, and also kind of the number of each healthcare worker assigned there. And so I took that and kind of plotted it a few different ways. This first one on Tableau, where it simply just lists the territory number, and then with it kind of corresponding values of each healthcare worker. And then in QGIS, I then plotted kind of that same thing, except made it graphical, where it shows kind of the different levels of each healthcare provider in a given health sector. And based on kind of these two ways of looking at the data, it seems that the model functioned well. It seems that the model distributed the healthcare workers effectively to where they needed to be. And so it seems that all checked out with the math and kind of the overall effectiveness of the model. And so with that kind of baseline idea of the model working correctly, we then looked into what's called a sensitivity analysis. And so with this, we took that parameter that was constrained in that flow constraint, the 0.002, and changed its values to a few different numbers, going below and above, and kind of seeing what was interesting and that emerged from that. And what we found is that pretty quickly the health benefit maximized. However, the distribution and kind of the changing of the health benefits looked a little bit different. And so we took, in this case here, our variable, or our parameter rather, of 0.02, changed it to 0.004. In my paper, I look at one other case of changing it to 0.01. But with that, you can see that there are some changes with the health benefit. And originally we thought that it would push, a lot of people, or a lot of kind of health benefit to those high population areas. But what the model actually did was actually push it more to the average. And so it kept the kind of high values, or high population value areas, more or less the same, sometimes adding kind of a few workers here and there. But overall, it kind of took the lower population areas, took healthcare workers, and applied those more so to the average areas, or the average population areas rather. Also with the model, there's a handful of limitations that I discussed pretty far in depth in my paper. But one of them is that this information's actually quite old now. Since I've been in Guatemala back in 2018, they've actually opened at least one, if not two, new health posts. And I've also kind of reorganized some of their staffing, and also kind of brought in some community aspects to the healthcare system. And so kind of with that, there's not exactly a strong recommendation that I can give, just since the data is almost kind of out of date and not necessarily most useful. However, I think it works pretty well in terms of showing a proof of concept of the capabilities of using operations research and looking at staffing and health benefit and things like that. So then moving into our future work, another big piece that could use a lot of sensitivity analysis would be on the marginal benefit. If you remember with our objective function, I'd mentioned with the, that kind of took our number of employees times their marginal benefit, or the benefit that that next worker provided. The model is currently based off of using kind of a diminishing returns type of model, kind of primarily based around x to the 1/2. However, there's a lot of work that can be done in terms of working that and tuning that to be even more accurate, and I think more accurately reflect the kind of realities of healthcare workers. In this case, we didn't necessarily have time to look to see if this had been already parameterized by anybody, but especially in this kind of specific case, a lot more time and detail could be put into that in terms of making it fully accurate, and I think more accurately reflect reality. I think there's also things that can be done to look at the practical information about healthcare workers, kind of how they do, or like where they are situated geographically already, and what's possible for the commutes. Also looking at years of experience, or other kind of sub-training ideas below kind of their effective titles. And then also, as I mentioned previously, getting updated data about the health posts, see if they're able to collect more accurate health statistics that maybe reflect kind of actual mortality rates rather than just the ones that are reported to the health posts. And I think kind of also look at how community and kind of biomedical system relations have changed over the past few years. But nonetheless, this model here, I think, which puts out the kind of numbers of healthcare workers for each health territory, I think still serves as kind of an effective means of looking and examining kind of all those different factors that go into distributing health workers, and doing so in kind of a mindful setting of ensuring kind of equitable healthcare for all those in the territory. So now we'll look at the literature review, kind of the final component of the independent study. And pretty much my goal with this literature review, which will be attached to kind of this page online, I was looking at some of the foundational information about mixed methodologies. So I examined sources ranging from 250 pages of a book to a handful of pages in just kind of a regular academic article. And my goal was just to kind of better understand what methodologies exist, kind of the breadth and the depth of what mixed methodologies look like. Just because kind of with this kind of mixed methodologies and this multidisciplinary viewpoint, I think it's a really foundational and important thing for me. On my website, I talk a little bit about holistic problem solving and what that means for me in terms of a problem solving methodology. But I think, obviously having that quantitative and that qualitative side of things is very important in terms of having a holistic and total understanding of the situation, and then being able to create really smart, decision-making tools and do really smart things kind of in those issues. And I guess kind of to step back, I'll briefly talk about what this looks like in Guatemala. But if you'd like to hear more about it, I invite you to check out the guest lecture I gave in medical anthropology. It'll also be linked in a number of places on this page. But within access to quality biomedical care in Guatemala, there's obviously a physical aspect that we looked at here in terms of both the GIS mapping that seems to show more so a relationship of proximity to health post mortality than anything else, and also kind of with the operations research model looking at distributing healthcare workers and making equitable care across the area. But there's also kind of a lot of non-physical access factors that need to go into play in terms of understanding kind of the difficulty in creating a simple solution in Guatemala. With the civil war that occurred there about 40 years ago, when Hueva was a hotspot, there's still a lot of, I think, underlying relationships and distrust between the people and the government, and therefore the healthcare system and things like that. And so kind of having that in mind and working to kind of bridge those divides by leveraging community support for different things and community leaders for different things is a very necessary thing. Also looking at economic disparities between the northern and southern part of Hueva, where the south is a lot better situated for agricultural production than the north, and thus the south is kind of on average a decent bit richer than the northern part of Hueva. And so kind of understanding those things and putting those things maybe into numerical terms or maybe just in qualitative terms to help describe the issues is very important. And solving one without the other is kind of ineffective because it doesn't necessarily tackle the problem in totality. It might have an incremental gain, but without the other, it's not really a full solution. So overall, I'd say this independent study taught me a lot about the learning process. Throughout the semester, we had the spring break and then the kind of outfall or the fallout from COVID-19. And so kind of throughout that process, both before and after, I learned a lot about facing frustrations, enduring failures, but then also kind of doing all of those things with the goal of building skills for the future. And I liken this to learning Spanish earlier on, when I would usually have to give public speeches when I went to communities, and would usually just totally miff them and just not have a good time. But kind of through all those failures and those frustrations of not being able to speak, I was able to grow, and now I'm approaching fluency and can look back on those with a lot more, I guess, joy. And when I was doing the GIS activities, when I was fighting the code on the model, it was a very similar situation where it was kind of a slog and not necessarily the most fun. But kind of through those failures, through those frustrations, through seeking help from my mentor, Dr. Jessica Hierstam, I was able to build those skills and grow for the future, and kind of continue to have that mindset of growth and skill growth, and a desire to learn to love. And with that, that's kind of the end of the presentation. I want to extend another thank you to my advisor and mentor for this independent study, Dr. Hierstam. at K-State. And then with that, Dr. Hirestone, did you have any questions or?
I do. Do you want those questions on the recording, or would you prefer them not to be?
We can put them on the recording. I can always cut this, so.
Okay, as you wish. So nicely done. I think it's clear that you've made some great progress on all of the areas that you had identified for skill growth this semester, not the least of which is resilience, right, and grit.
Mhm.
So working through those challenges definitely will continue to serve you well, especially as you go to graduate school. And continue your independent work. So thank you for the opportunity to work alongside you and to listen to the presentation. My first question is, so what insights about these problems do you think that you are now able to provide that you couldn't have done if you'd approached it only from the anthropology side or only from the industrial engineering perspective? You hit a little bit on it with the
Mhm.
access piece there at the end, but is there anything else you'd like to speak to specifically about the value of bringing both perspectives to this setting?
How I've used kind of the metaphor in the past is I've described it as climbing a ladder, in the sense that you need both the kind of quantitative and the qualitative sides, I think, to make really strong, lasting change. And so you could probably climb a ladder on one side, but it's a lot more difficult than, balancing out and kind of having, your hands in both camps. Um, and if you look at kind of the quantitative side, I think you do get a lot of value in terms of optimizing a system, creating it so it's easier for people to access physically. They're able to go to, physical sites and receive that care. But I think, kind of what I discussed very rapidly earlier on is without that qualitative side, without understanding the fact that, there is a level of mistrust between, some community members and, the biomedical system. Without, addressing that issue, you kind of solve one aspect of the problem, which is, the physical access to care. But even if you pave all the roads or build a health post right next to someone's house, it doesn't necessarily mean that they actually will access it,
Mm-hmm.
based on some of those kind of more qualitative issues. And so I think, kind of from this independent study, I definitely gained the ability to do the quantitative piece. Prior, I've had experience using CPLEX working in OPL, but haven't necessarily ever used it on something practical or I think real. I
Mm-hmm.
think it's a lot harder to go from having a data set and a general idea to an in-game and a model and outputs than it is to, get a piece of paper with, one of our projects was, I think, Bob's car sales, and all the information needed is listed out there. Um, and so I think, yeah, kind of getting that data and then having to clean it and go through it and try to work out exactly what I wanted the model to be was a lot more useful and I think practical in terms of showing me what that process actually looks like in real life, where it's not just kind of a cut and dry situation. It's something where you have to kind of go in and chase out those answers. And then with
Mm-hmm.
GIS, I've always wanted to be able to show things on maps and make really cool graphics about maps and kind of show things geospatially. And before I just never had that ability. And now I'm able to take statistics and take information and plot that, in a way that can be visualized and tell, I think, a far more compelling story than a chart would be. And so I
Mm-hmm.
think kind of from those two pieces, I think there's definitely a storytelling part, which you might even say, obviously it's a quantitative process, but I think it's a qualitative outcome in terms of the sense that most people look at maps and don't, deduct the numbers and the values from it, but they get, kind of a story out of it. And so I think having that kind of, I don't know, I guess you could say almost a mixed methodology in a sense with the GIS, and that really strong kind of quantitative background with coding and using that OPL to create a model of worker distribution is really useful.
Mm-hmm. Great. Um, So, one way that you've been able to combine this understanding of the cultural aspects and the qualitative, if you will, components with the quantitative is to actually major in two different
Mm-hmm.
disciplines. This is not something that most of our students would do, but obviously it sets you apart in terms of your own professional goals. But do you think that there are ways that as industrial engineering professors, we should help students be more aware of these factors, and how might we do that, say in the course of an operations research class?
I think kind of in a quick sense, you know, when you think about kind of the outcomes of industrial engineering, a lot of students kind of focus on those like kind of basic fundamentals, you know, where, you know, when you give an industrial engineer a job, they don't instantly start thinking about the algorithms that they know, but they kind of start with those foundational pieces of knowledge where, you know, fundamentally as an industrial engineer, you know, my interest is in optimizing or improving the system for, you know, both the users and the people down the line. And I think it's a very similar thing in anthropology where, yes, there's a lot of kind of specifically anthropological skills, ethnography and thematic analysis and all that. But I think fundamentally when you hand an anthropologist a problem, kind of a similar thing happens where they go back to their foundational roots, which is kind of, you know, kind of, I guess, primarily based in a way of seeing the world and kind of dissecting the world. And so I think kind of within, you know, an industrial engineering setting, the easiest way to kind of provide maybe more qualitative outlook on things is kind of providing a different way of seeing the world. You know, in anthropology, we talk a lot about holistic vision, or kind of seeing the small details, seeing the large global systems, seeing the histories and everything that's kind of coming to fruition in this moment. And I think being able to put all those different ideas together is what makes, you know, a really good anthropologist. And so I think even just, you know, in a simple operations research class, you know, it's hard when you have, you know, kind of a hard paper, you know, kind of definition of a project. But I think talking about the kind of maybe underlying realities and thinking about kind of the ramifications of a model and recommendation are kind of a key component to building, I think, smarter decision makers and maybe holistically minded decision makers, in the sense that, you know, a model puts out numbers, but then taking those numbers and thinking about them, and maybe, you know, depending upon the situation, discussing those numbers with people that have a stake or, you know, have, you know, kind of some form of impact from that outcome, and working with them to kind of see their seeing on what that answer would provide them or cost them or things of that nature, and working kind of through that solution process with them. I think it a lot of times comes down to, you know, maybe not even necessarily, you know, gaining that vision yourself, but trying to get that vision to come out of somebody else, in terms of, yeah, their understanding of what the ramifications look like of a model, and then being able to kind of internalize those and work out maybe a better or a different solution from that.
That's great. I want to make sure that Dr. Klataski has an opportunity to ask questions if he'd like to do so. You're still muted.
Sorry about that. Thank you for inviting me to join you. I'm sorry I was late, got tied up in childcare. I don't have any questions, but everything that I saw looks fantastic. And I think you have done a great job of integrating these different perspectives and approaches. And your explanation to this last question was spot on, in my opinion. You did good work.
Fantastic.
Excellent.
All right.
Ethan, is there anything else you'd like to accomplish today?
I don't think so. I think that's everything.
Okay, nicely done.
Thank you.
And I wish you all the best with the rest of your finals week. I know I owe you a letter shortly after grades get posted, so I'll make sure that that gets delivered on time.
Perfect. All right. Sounds great.
All right, take care. Let me know if there's anything else that you need, okay?
Okay.
All right, bye-bye.
Bye.